Hi, this is Dr. R. Esther Felicia, Head, Department of Mathematics, Sri Krishna Swami College for Women. Today I am going to present you in this video the topic Predicates and Quantifiers in Discrete Mathematics. Predicates and the quantified statements. We should know what is a proportional function or a predicate. A proportional function or a predicate is a sentence that contains one or more variables which can vary as much of times, and a predicate is neither true nor false, and it becomes like a proposition or a statement when the variables are substituted with specific values. The domain of this predicate variables is a set of all the values that may be substituted for the variable. Below, I have given the table, that is the examples, by using the functions, the symbols, predicates and the domains and the propositions. P of x with one variables, where your x is greater than 5 and x belongs to R, a set of real numbers, and a proposition functions P of g and the P of the values. The next one is a truth set. A truth set of the predicate is a set of all values of the predicate that makes the predicate true. If P of x is the predicate and x has a domain D, then the truth set of P of x is a set of all elements of D that makes P of x true when the values are substituted for x. That is, the truth set is defined as P of x is equal to a set of all elements x belongs to the domain D, where that belongs to the function P of x. And below I have stated some symbols, predicates and the domains and the truth sets. We can see the two variable symbols P of x comma y, where x plus y is odd, x belongs to z and y belongs to z, where P of 4 comma 5 and minus 4 comma minus 3, the values belong to that statement. The next one is predicates to proposition. Two methods can be obtained from propositions, from predicates, and which assigns specific values to variables and add quantifiers. Then we should know what is a quantifier. Quantifiers are the words that refers to quantities such as all or some, and they tell how many elements a given predicate is true. For how many values it can be true. Introduced into the logic by logicians Charles Peirce and Gottfried during late 19th century. Two types of quantifiers is a universal quantifier and the exponential quantifier. The universal quantifier is a statement of the form for every x belongs to D, P of x exists. That is for every x, where you can have the forms P of x or z is true for all the values of x, for all x P of x, for each, for every and given any. All these statements belongs to the universal quantifier. The next one is the universal quantifier, an example, that is a symbol for every, and universal set and the domain. For every z belongs to D, I can have a z squared is greater than or equal to x, where D takes the values from 1 to 3, and it is a finite set. The truth value is true and the method of exhaustion. Similarly, there is a method of exhaustion cannot be used to prove universal statements for infinite sets. Next, you can have an exponential qualifier. Here, the exponential qualifier is a statement of the form there exists x belongs to D, P of x. There exists. It cannot be referred for every values. And for some x or there exists, we can find such, and there is some, and there is at least. All these words can be the initiation of the sentence which exists in exponential quantifiers. So these are some examples of exponential quantifiers. Then is the universal set, domain was given in this finite set, the truth value either it is a true or false, and the method, whether it is a method of exact or what it exactly prefer. And this is a problem we can have expressing the negation of the statement for every x there exists a y, xy minus 1, so that the no negation proceeds a quantifier. You can solve using our rules with universal or exponential quantifiers. And this is a table which refers to the statement, and you can predict whether the statements are true or the statements are false. That is for two variables or single variable. Thank you.